Hi everyone, so welcome to this session. In this session, I'm going to solve one question from Bayesian Network, and this question was asked in GATE 2024 in GATE Data Science and AI paper, right? So, in fact, there were more than two questions, right? Based on this Bayesian network. In fact, one question was also from DAG, right? Because this Bayesian network is basically motivated by DAG concept. I think many of you might have seen in my videos that directed acyclic graph. So one, you can say one kind of graph will be given, and you have to write the joint distribution, right? Using that network, using that Bayesian network. And basically Bayesian network is used to investigate conditional independence. Okay, see, we know the independence of two event. Okay, probability of comma b is equal to product of the individual properties if they are independent. Okay, if there are more than two events, so we claim that they are known as collection wise independence, right? Okay, collectively they might be independent. So whenever many events are independent, means we always take the product of them, right? Okay, if we are computing the joint probability. Okay, so in this question what was given, let us see here. Okay, and what they are asking, right? So the question is in front of you. So this was the question which was asked in GATE 2024 in data science and AI, and this question was for 2 marks. Okay, so it's a very simple question. Okay, what they have asked here is, given the following Bayesian network consisting of Bernoulli random variables and associated conditional probability, okay, tables. So they have also given the conditional probability table here. Okay, you can say, see here, probability of e equal to 0 is 0.5, probability of e equal to 1 is 0.5. Okay, so your observation must be very clear. Okay, and you should not have any sort of fear while solving the question. So this is the table, conditional probability table they have given, and they have also given the Bayesian network, right? Okay, and this kind of Bayesian network you might have seen DAG also. It looks the way we have drawn here the Bayesian network, but here you can see how many nodes are there. There are four nodes in the sense that there are four random variable, u, v, w and z. There are four random variable. So what question they have asked in is you have to find the value of this, this is nothing but your joint joint distribution. They are asking joint distribution, I mean joint probability, you can say. They are asking joint probability to compute. Okay, joint probability. Let's say you have got two random variable, right? Joint probability they are asking. Okay, and all the random variables are taking u equal to 1, v equal to 1, z equal to 1, w equal to 1. Let's say you have got two random variable. Okay, so how do we define joint probability? That is nothing but ordinary probability times the conditional probability. But here they have given four random variable, so it is very hard to you can also use multiplication rule and all, but that is very difficult, right? Since they have given the Bayesian network, it is very easy, as long as finding out the joint probability. So we can write from here the joint probability. You can say that u comma v comma w comma g, right, is going to be equal to what? See, keep in mind, this is very important when you are solving Bayesian network problem. So these nodes represent basically the random variable. Okay, so there are four random variable. If there are five random variables, so they will be giving you five. And these arrows are very important. You see, this network is acyclic. Okay, there is no cycle at all. Acyclic means what? There is no cycle. Okay, you can't go back. You see, you are coming from u to v. Okay, so your v should come after u only. Okay, you should not come after v. Remember that. If okay, so u, then it should come v. Okay, understand? Then it should come w, then g, right? Or you can also say like this: u, then okay. So this is the ordering that you have to make sure, right? Okay, u, v, w, g. I hope this makes sense. Okay. So you have to make sure this, or you can say that, see, after you v is coming, then w is coming, or w is coming, v is coming, right? So you have to make sure that this order. Okay. So how can we write this joint probability, from this Bayesian network. So we are starting with U, okay, U node you can say. So it has only got the ordinary probability, okay, associated. So you can say that this is nothing but probability of U, right, times, then you can come to here. So this V, probability of V given that U, we have to write probability of V given that U, right, because already U has occurred, right? So you have to write probability of V given that U times probability of W given that U, probability of W given that U, okay, you have to write like this. Then probability of G, you have to multiply the probability of G given that what, V and W. Okay, so this is how we can write, uh, you can say that the joint probability, okay. This is how we can find out joint probability, and all the values are given in the table. So it was very simple question, and you have to just find probability of U equal to 1, V equal to 1, W equal to 1, G equal to 1, okay. I can again write this if you want, okay, because clarity should be there. So I'm just going to take this guy from here, and you should be very comfortable if any uh, Bayesian network is given, or see what kind of question they will be asking. They might give you Bayesian network and you have to find joint probability, okay, that is very simple. And if they will give you joint probability, okay, probability of 4 to 5 random variable, right, jointly occurring, understand. So you have to draw the Bayesian network and then you can investigate conditional independence among the random variables, okay. So that question was also asked. That is the beauty of the paper, in GATE 2024, and it was very easy and anybody can solve it. Okay, so you see this U and V. Now let us write this. Okay, so I'm not considering this equal to 1 and all. Just write U, V, W, and G, which is equal to, starting from this node. Okay, you can say from this. Okay, so you can say that probability of U, because no other random variable is there, okay, before that. And after that, this V is occurring, right? So you can say that probability of V given that U, probability of W given that U, okay, then probability of G given that jointly occurring, V and W. I hope this makes sense. You guys can write like this. Then what you have to do here is you have to find the probability of U equal to 1, V equal to 1, W equal to 1, and G equal to 1. In fact, you don't have to write all these things. Directly you can choose the values, right? So you can say probability U equal to 1. This is V equal to 1, U equal to 1. Okay. And then probability of W equal to 1, U equal to 1, right? Probability of G equal to 1, right? So because they are asking you to compute the uh, you know joint probability, okay, at particular value, right? So you can say G equal to 1 given that V equal to 1 comma W equal to 1, right? So all these values are given in the table, right? Can we have the loop? Yes. Probability of U is nothing but 0.5, right? So you can just write here 0.5, 0.5 times probability of U equal to 1 given that U equal to 1, probability of V equal to 1, right? So let me go back and check. So you see guys uh, this table, okay, you have to refer this table, okay. So given that U equal to 1 dot, in place of dot you have to say U equal to 1 and probability of V equal to 1. So that is nothing but 1, guys, you see. I hope this makes sense. No, it is not. This is the value. Okay, please remember that I looked at W1, ठीक है, इसको आप मत consider करो ये. So what is this? Probability of V equal to 1 given that U equal to 1. Okay, you can just have the, this table, that conditional probability table they have given. So this will be also 0.5 times. This is basically what? You see, now you have to come to here. So this is going to be 1. So I can just multiply 1 and then you have to go to third table. It was very easy question, right? You just refer this table. So you have to just look at this and you have to look this, so 0.5 only. So this is 0.5. So if you multiply all these guys, so you'll get 0.125. Okay, so what they are asking is you have to answer this question up to 3 decimal places. So answer is 0.125. Exact answer you are getting. Okay. So this is how we solve the Bayesian network problem, right? So whenever Bayesian network is given, you can write the joint, you can find out the joint probability, okay? And whenever joint distribution is given, right, joint probability is given, or joint distribution is given, you can draw the Bayesian network and you can investigate, conditional independence, right? So I hope you might have understood this. See, you don't have to write these formulas. Let me tell you, only joint probability you have to write, and then directly take the value from the table and multiply it. Okay, don't write and waste your time. Okay, because in the gate examination you have to get at the end of the day the answers, and answers should be correct. So at least you can write the formula, because writing the formula will give you kind of idea. Or if you have practiced enough, you don't have to write that also. Starting with probability of u, so 0.5 into, then you have to multiply conditional probabilities. Okay, given that u for v and w, so multiply again 0.5 and 1, and then 0.5. Answer will be 0.125. In fact, you don't have to write anything if Bayesian network is given. It depends upon your visualization, right? How far you see, okay? How much confident you are, okay? So that is also very important criterion to be able to handle these kind of question, right? So I hope you guys might have enjoyed this solution. So please again take one A4 sheet paper and try to solve the way Dheeraj sir has solved, right? Certainly you might expect some question in GATE 2025. So we'll meet in the next session and we'll take again one more question from Bayesian network. Okay, and we'll apply the same concept. Thank you.